this session is about orchestrating a physical network function. Some of you may wonder how an orchestrator can do something about a physical network function that is already there. And the thing is that we are able to configure existing network functions, physical appliances that are already there sitting in the data center in the network. Why would we need this? Well, because you may have noticed that sometimes when we deploy a network service, when we deploy in general some network service in a data center, in a network, we have some virtual elements, and we also have to touch some configurations in physical elements to make these virtual elements work. So we have network services that depend on some configurations in an upstream router, switch, load balancer, firewall, and that is a physical function. So orchestrating a PNF gives us the opportunity to launch our virtual network services, or VNFs, and go and touch and configure the PNFs that have to do with a service that we want to provide with the virtual instances, so that they are configured automatically and our network service starts and deploys in a state of being able to function and to give the services from day one. So that's the idea of being able to control a PNF. So in some terminology, PNF is a physical network function. It's the equivalent of a virtual network function, but physical, it refers to an appliance. PDU is a physical deployment unit. It refers to, we can call it an abstraction of the PNF. So it's an instance of the appliance that will be used in our network service. Okay. HNF is a hybrid network function. It's composed by both physical and virtual elements. So we have we can have a mix of physical and virtual deployment units in the same network function. We can have physical network functions and virtual network functions in the same network service as well. So we can have a mix of everything. In OSM, there are no differences on how we model a network function or a PNF, I mean a virtual network function or a physical network function. And we use the same model. We use the same kind of descriptor. Of course, we would not need a flavor. We would not need to say, I want this amount of CPU, I want this amount of memory or disk, because it's a physical network function. But we do need a way to identify it, and of course we would want to set some configuration that we would like to apply. Okay, so what we need to do to orchestrate, to go and configure a PNF as part of a network service, is to instruct OSM that there is a PDU, that there is an abstraction of this PNF available for me. So there we have this concept of PNF and PDU. The PNF is modeled in a descriptor. So it has a PDU type and some interfaces and name of the interfaces. And when I deploy, I obtain these instances of a PNF. So the PDU, which is the instance, has a type, it's associated to a Vim account, has interfaces, so that the types in the descriptor and the PNF descriptor and the PDU descriptor should match. So at the end, I have to define two files. One that will model the network function that I want to deploy, in general, and the other one that will model the instance that is available for me. So we can have different instances of routers, for example. I have a router with IP address 10.1.1.1, and I have another router of IP address 10.1.1.2, and I have another router with IP address 20.1.1.100. So there are three different routers that are described in this PDU file, and they are of type router. So in the PNFD, I just define what type I want, what PDU type. So whenever I instantiate a PNF, it looks at the type and says, okay, I need a router. I don't mind if it's, I don't mind about the IP address. I don't mind about the implementation. I just want a router. So it would consume one of these PDUs that you defined in your system. Okay, so it's an additional step, just creating the PDUs so that the system, OSM, is aware of an instance, a logical instance of the physical appliance that I can use when instantiating my PNF. Okay, so what we are going to do, following a little bit, going back to this diagram, what we did the first day was we instantiated, we prepared, built this DNF, which is formed by two PDUs, no? The Mac-Access Gateway, which is a packet core, and emulator. Then yesterday, we built this orchestrator of Magma, which we say is just a manager of this access gateway, manager of this, and we can have hundreds of these access gateways under the control of this orchestrator. Then we built some relations between both of them so they could be configured automatically. So some of you had problems there. You would have the opportunity to fix that today. And so we covered these two, and now we are adding this PNF so that we have a path for our user to go to the packet core, register, attach, and then actually navigate to internet or to the services that we are going to add later. So this is a router that is in the middle right now, and we want to be able to control it. Okay, so this physical router here has, I'm going to show, you see, in this tenant here, we have this router. It's a BIOS PNF. The first day I accessed the console, it's just a router, a small router. It's just standing there. It's there connected to the management network that can take you to internet. And the other side is connected to a network called SDI, which is the same network for everybody. And the IP address that this PNF has is that .7. So it's this router here. Everybody will use the same router. You will share the same router. You just need to create an instance, a logical representation of this router so that it can be included in your network service. And this Magma BNF and this PNF will build a network service together. Okay, so what you need to do, you can do this through the dashboard or through the CLI. I have not personally tested this in the new dashboard, so you're welcome to do that and share the results. Actually, I don't have the right screenshot, just realized that. But you can do this through the CLI. You just need to create a file, a YAML file. You can call it pdu.yaml. You can call it whatever you want. Let's say that we all call it pdu.yaml. You put it in your home directory, for example, where you're going to launch your network service, for example, your working directory. And you put this content. we are calling it router 1. We're giving it a description, but this is not relevant. This is relevant, the type. We're saying that this is a gateway, a data center gateway, for example. Then, Vim accounts, between these square brackets, you put your Vim ID. I mean, if you do a OSM Vim list, you will get an ID, and that ID, you put it here. Then the rest is the same. It's not shared. You have a couple of interfaces that just modeling, describing the actual router. It is connected to a Vim network name called OSM-MR with IP address, this IP address, and then it has this other IP address. It's just a representation of the router. When you create this, as soon as you have the file, whenever you want, you just create it in OSM PDU create, descriptor file PDU YAML, and that will create the instance for you. And now you're ready to use it. In the graphical interface, you will have something like this. This is from the old user interface. In the new one, you will have a similar form. Yeah, and you put just the same parameters, and you will be able to choose the Vim account instead of grabbing the ID manually. So maybe it's better for you. And you just need to put, it's important for you to put the management network. This is the most important parameter. The IP address of management and the management, and say that this interface here will be the management network. Just as we put here, management true. This is important. Why is important? Because when you instantiate the PNF, I mean, instantiate or get access to a PNF, you will want to configure it, and OSM would need to know to which IP go and run the proxy channel, for example. So this is the IP address that it will take if you define management true, and this is the IP address that it actually has in OpenStack, in the NFDI. So it's important that you define the management true parameter. Okay, and that's it. Create a PDU. That's the only thing that we're doing in this session. Okay. Then you will have the opportunity to, in the next session, to create your new PNF. It's just a new descriptor that you will obtain, and it's very similar in structure to the MAC Access Gateway descriptor, but in this opportunity you will not see any flavor or any parameter that refers to a virtual instance. You will just see a PDU named Gateway PDU and of type Gateway, and this is these two parameters. This single parameter PDU type is indicating OSM that this is a PNF, and it has to go to the list of PDUs that we're creating in the system and grab one instance and mark it as used, so that no one else can use it again. Okay. So you are creating a new PNF, and then you are making it part of your network service. So remember, your network service today, the network service of MAC Access Gateway, just has a single VNF with two PDUs, which is the VNF that we call MAC Access Gateway SRS LT. Now you're adding a second VNF that is actually a PNF, which will be called BIOS PNF, and connected to the same network. And that's it. With this, you have now a network service which is comprised by a PNF and a VNF. And finally, in the automation session, we do what is important, which is configure the PNF, because we are not adding this just to just have it there in our network service. We want to do actually something with that PNF, which is configure it. So you will see that configuration with David in the next session.